Hello. Welcome to your next video. This week we are looking at measurement problems. Now, a few weeks ago we had some work looking at reading scales of different types. So that's using the knowledge that you learned there to then solve some problems. Okay, so we're going to do a quick recap of reading scales and play a game online together, and then we're going to solve some measurement problems. Right, so to start off, we're going to play this capacity countdown game, which you can find online. I will put the link in the description underneath the video so you can have a go at home. We're going to start with answers in steps of 10 millilitres. So click on the green arrow and it will give you an amount of liquid which you need to read, find out how much liquid's in there by reading the scale. Now, if we just have a look at the scale before we start, we can see that we've got 0 at the bottom and we've got 100, 200, 300, 400 and 500. Now remember, you need to look and see how many little lines, how many intervals you've got in between. You also need to look for the middle line, and in this case it's also been given to us in blue to stand out. So if the middle line here is blue, you need to think about what number would be in the middle of 0 and 100 and in the middle of 100 and 200. So what number would that be? Have a little think. So this number here would be 50. And so if we just have a look at the other lines that we've got, I wonder if you can work out what one line is worth. If you went up just by one line each time, how many millilitres would you be going up by each time? If 50 is in the middle, we've got 100 here, we've got 0 here, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intervals in between. So 100 divided by 10. Have a think. So each line would be 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That would continue 110, 120, 130, 140, 150, all the way up. So let's see, can you work out what the amount of liquid is inside this rocket? So let's have a look. See if we can work out how much there is. We know this is 50. It will be 60. So you just type it in, click check. Well done. Okay, new rocket, and then we click on the green arrow. Now we're going to do 4 of these, and I'm going to pause in between each one. I'm not going to talk much about it because I want you to recap reading these scales, but what I recommend is that you pause the video so that you can have a really good look. But I'll pause for about 5 seconds myself before I type in the correct answer, but please do pause the video so you can look, you can work it out, and you know what the answer is before I type it in. Okay. So the answer is 40 millilitres. Oh, that's a small one. Okay, now the difficulty here is that it does actually start with 0, but you can't really see the liquid from 0. So, but it does go up to the second black line there. So it should be 20 millilitres. Oh, much further this time. Have a think about this one. Pause the video. And the answer is 250, 60, 70, 80. 280 millilitres. And the last one for this level. Oh, what do we think? The answer is 250 millilitres. Right, I'm going to pop back to the menu now and have a look at another level. We're going to have a go at the steps of 25 millilitres now. So have a look at this scale. It's a bit different to the last one. We've still got the hundreds marked on, but there aren't as many intervals or lines in between. So you need to have a think and work out what each of the intervals could be and what we're going up by each time. Now there's no middle line, no obvious middle line anyway, but you might be able to find a middle line still. It's not blue this time, but you might be able to work it out if you look closely. What do you think? So if we have a look at the intervals and the lines in between, we've got 1, 2, 3, 4. So there's 4 sections in between, getting us up to 100. And the black line here in the middle is our middle line. Okay, this the second black line out of the 3. Okay, the one in the middle of the black lines. So what's halfway between 0 and 100? 100 and 200, same as last time. What would that be? That would be 50. And so halfway between that, because we've got another line in between before we get to 100, and before we get to 50, there's a line in between from 0. So what would each of these lines be? What is it actually counting up by? So it's 100 divided into 4 sections. So remember, if you're dividing by 4, you can half a number and halve it again. So half 100, half it again. What do we get? We get 25. So each of these lines is 25 millilitres. 0, 25, 50, 75, 100. 125, 150, 175, 200. 225 all the way up. Okay, so let's have a look. Can we work out what this scale is reading? We've got the 100 line here, but it's the next one up. So what would that be? It would be 125 millilitres. Okay, I want you to have a look at this one on your own. I will pause for 5 seconds. Oh, gosh, it's a long way up. So that is on that black line there, even though it looks slightly like it's not. Okay, so you have a look at this one, pause the video and work it out, and then I'll give the answer. Okay, so the answer is 900, and on the first line, 925 millilitres. Nearly at the top. Okay, we're going to do 3 more. Right, have a look at this one. Pause the video, have a think. So this one is 425 millilitres. Oh, have a look at this one. Okay, so we're in between 600 and 700, the second black line along, so 650 millilitres. And the last one, what's that one? This one, halfway between 100 and 200, so 150 millilitres. Okay, so we're going to pause there for now, but as I said, I'll put the link in the description under the video so you can have a go as well at the game. I would recommend doing the ones that we've done, so the 10 millilitres or the 25 millilitres, but you can have a look at the other ones as well, but you might find some of them a bit easy, but you can have a look and see all of those different levels and have a go at that. Okay, so now we're just going to have a quick look at the questions that we're focusing on this week. Right, so these are the questions which we are focusing particularly on today from your book. It's from page 39, questions 7, 8, and actually we're going to look at 9 briefly as well. Now, I'm not going to work these out with you, but I will talk through them now, and then we're going to look at some other problems, measurement problems, and we'll work through those together, and then you'll be able to come back and have a go at these. Okay, but I'll talk you through what you have to do, because actually you're very capable of doing these ones yourself. So number 7 says, the diagram shows water in a container. Josh pours 250 millilitres of the water away. How much water is left in the container? Now there's 2 parts to this question. We need to work out first of all how much water is in the container, because then when the 250 millilitres is poured away, we need to know how much water has been left. Okay, so job number 1 for this question is to work out, put number 1 here just as that's your job number 1, is to work out how much is currently in the container. Okay, think about the scale that we've got here, the middle lines, how much is in here, and then depending on how much is in there, whatever you work that out to be, the second job is going to be taking away the 250 millilitres that Josh pours away, and then you'll see what you would have left. Okay, so you work out what was in the container, and then you take that number and you take away the 250 millilitres which is poured away, and you'll be able to work out what's left. That's quite simple. Number 8, Saba has some square tiles. Each tile has a width of 50 centimetres. Now if it's square, it means that all the sides would be 50, doesn't it? Saba lays the tiles side by side in a line. How many tiles will she need to make a line 2 meters long? Okay, so it sounds a bit confusing, this one, but if you think about it visually, it's much easier. So basically, Saba has tiles and she's lying them side by side in a line like this. Okay, now we know, not very well drawn tiles, unfortunately, we know that each tile is 50 centimeters in width. Okay, so from the top to the edge of each tile, okay, it's 50. So you need to work out how many 50s you need to get to 2 meters. Now, this is in centimeters and this is in meters. So what you do need to know is you need to think about how many centimeters are there in 2 meters. How many are there in 1? And then how many are there in 2? How many centimeters in 2 meters? And then that will help you when you're adding 50s, so you'll know when you get to the right number. Okay, and you just have to put how many tiles she would get to in the box there. Okay, so work out how many centimetres in 2 metres and then count in 50s until you get to that amount and see how many tiles you needed. Okay, I've just drawn lots out here. This isn't the right answer. Okay, just to demonstrate what she's doing. Okay, and then number 9, it says a carton holds 2 litres of apple juice. Emily fills 12 glasses with apple juice. She puts 100 millilitres in each glass. How much apple juice is left in the carton? Give your answer in millilitres. Show your working. Now, again, there's 2 things you need to do here. Okay, we know that Emily is going to fill 12 glasses. Okay, and in each, there's going to be 100 millilitres. Okay, so she's going to be doing 12 lots of 100. Okay, now you'll be able to work out what that is. You can use the head dance to work that out, 12 times 1, and then do the head dance. But what you then need to think about is, because we're thinking about millilitres here, and it says give your answer in millilitres, we need to convert 2 litres into millilitres. Okay, so you need to work out how many millilitres are in 1 litre and then how many millilitres would be in 2 litres. And I'll give you a clue. The number of centimetres in a metre is not the same as the number of millilitres in a litre. Okay, there's more millilitres in a litre than there are centimetres in a metre. Okay, so work that out. How many millilitres is 2 litres? Work out how much you would have for 12 glasses of 100, and then you need to work out how much is left. Okay, so the answer is not this calculation. The answer is whatever would be left over in the carton. Okay, so remember that. Right, we're going to have a look at some other problems now, which we'll work through together. I'll talk you through them and I'll give you some time to have a think, and you can pause your video as we go along, and hopefully you'll be able to come back to these and be really ready to answer them. Okay, so this is our first problem. Lenny's toy car weighs this. So look at the scale. Use this to work out what the other children's cars weigh. Now that's not all of the problem. We do have little clues about the other children's cars as well, which I'll show you in a second. But what I want you to do just first of all is work out what Lenny's toy car weighs. So have a look at the scale and have a think about what that could be. It's halfway between 4 and 5 kilograms. How would we say that measurement? Have a think about it. It'll be really good if you can have a piece of paper here so you could write down the measurements along with me. Okay, so have a look at that. Pause the video if you're not quite sure what that weight is, and then we'll move on to writing down the answer. Okay, so what did you get for the weight of Lenny's toy car? Now there's 2 ways to write this. You could either write 4.5 kilograms, okay, which could be written, do this in a different colour actually, could be written as 4.5. Remember that we know that 0.5 is a half. Okay, 4.5 kilograms. Now you might have written 4.5 kilograms. That's okay, that's right as well. But we could also think of this as 4 kilograms. And how many grams would that be? How many grams are there in a kilogram? I'll give you a clue. It's the same as millilitres in a litre. There are 1,000 grams in a kilogram. And so if we've got half a kilogram as well, how many grams do we have? We've got 4 whole kilograms and then half a kilogram. So if 1 kilogram is 1,000 grams, how many grams would be in half a kilogram? So it would be 500 grams. So Lenny's car weighs 4 kilograms and 500 grams. Now we're going to have a look at the clues for the other children now. Right, so here are our clues about the children. So we need to work out how much their cars weigh without looking at a scale. So Emily says, my car weighs 1 kilogram more than Ben's. So we'd have to work out how much Ben's was. My car, this is Ben, my car weighs 200 grams less than Lenny's. And Jacob says, my car weighs 1 kilogram and 300 grams less than Emily's. So Emily's weighs 1 kilogram more than Ben's. Ben's weighs 200 grams less than Lenny's. And Jacob's weighs 1 kilogram and 300 grams less than Emily's. So who are we going to start with? Who can we start with? Because you have to do these in a certain order. We can't work out Emily's, for example, because we don't know what Ben's weighs. So who are we going to start with? So we're going to start with Ben. Okay, so Ben. My car weighs 200 grams less than Lenny's. So have a think about the measurement you wrote down for Lenny. And Ben's car weighs 200 grams less. Right, so Ben's car, as we said, weighs 200 grams less than Lenny. Okay, so let's have a look at Lenny. So if we're doing grams, I think we probably should stick with this measurement here because that will make it easier. So what is 200 grams less than this here? 200 grams less. You can pause the video and write it down and we'll see if we agree. Okay, so the 4 kilograms would remain the same because we can take away the 200 from the 500, leaving us with 300 grams. Okay, so that is Ben's weight of his car, 4 kilograms and 300 grams. Right, let's have a look back at our problem again. Okay, so whose can we work out now? We know Ben's. Whose can we work out next? Emily, that's right. Now, Emily's car weighs 1 kilogram more than Ben's. 1 kilogram more than Ben's. So let's have a look. 1 kilogram more than Ben. Okay, so let's have a look at Ben's. What would 1 kilogram more than that be? Quite easy, this one. 1 kilogram more, we would now have 5 kilograms rather than 4. And we'd still have our 300 grams. So that is Emily. So now we just need to find out Jacob's car weight. So Jacob's car weighs 1 kilogram and 300 grams less than Emily's. So 1 kilogram and 300 grams less than Emily's. Okay, so 1 kilogram, 300 grams less than Emily. Okay, so let's have a look at Emily's. 5 kilograms, 300 grams. Jacob's is 1 kilogram, 300 grams less. We need to take away 1 kilogram and 300 grams from Emily's amount. So what would we be left with? So we'd get rid of a kilogram. And we also need to take away 300 grams. Well, that's nice and easy. So there's no grams left. So his car is just 4 kilograms. There we go, we've solved the first problem. Let's have a look at the next. So we've got a set of scales here with some weights, some red circles and some yellow squares. It says here is a balance, and then next to it, here is another. Work out the value of the yellow square. So we need to start by working out what a circle is worth. Because if we don't know that, it's going to be tricky to work out the yellow square. And both balances, in both pictures, the circles are worth the same amount. Okay, it's just another balance with more circles on the second one. So let's have a look at the first one on the left. We've got 6 kilograms. And then we've got 2 circles, and you can see that the scales are balanced. Okay, it's not one side that's heavier than the other. It's balanced. So if we've got 6 kilograms on one side, what would each circle weigh? So for 6 kilograms, we have 2 circles, which will be the same. So what would that be if we were going to split 6 kilograms between the 2 red circles? How much would they be each? Pause the video, have a think, and then I will reveal the answer. Okay, and the answer, each red circle is worth 3 kilograms. Because 3 and 3 make 6, so that would make the scales balance. So we know that each red circle is worth 3 kilograms. So let's put that onto the other scales on the other side too. So here we can see that all of the red circles are worth 3 kilograms. Now we can work out the value of the yellow square. Now the black weights on the left have changed on this set of scales. So what have we got now? We've got 15 kilograms and we've got 100 kilograms. So they're both together. So we've got 15 kilograms and 100 kilograms. And that is making the scales balance with what is on the right-hand side. Now, obviously we needed more black weights, heavier black weights, because we've got more on the right-hand side. But we need to work out the value of the yellow square. So what we need to do is we need to work out the total of all of the red circles and then see if we can use that to help us work out the value of the yellow square. So what I'd like you to do is add up all of those red circles on that scale on the right hand side. So there are 5 red circles. So add them up, they're 3 kilograms each. How many kilograms does that make in total? So the total of that will be 5 lots of 3 is 15 kilograms. So we've got 15 kilograms worth of red circles. And on the left with the black weight, we've got 15 kilograms and 100 kilogram weight. So what must the yellow circle weigh? Sorry, the yellow square weigh? Have a think. Pause the video if you want to have longer. The answer is 100 kilograms. Now that one may have been very obvious to work out because we've got a 15 kilogram weight for the circles and then the weight that's left is the 100 kilogram weight. So the yellow square must have been the 100 gram weight. So that's what the yellow square is worth, 100 grams. Now I'm going to show you another example of this question. It looks exactly the same, but the numbers are different. And I'm not going to talk you through it this time. I'm going to pop it onto the screen and I would like you to pause and I would like you to work out the value of the yellow square. And then I will reveal the answers. Okay, so make sure you pause so that you can work it out and then I will reveal the answers. So again, you just have to work out the value of the yellow square. Right, so here is the second problem. Very similar, but the numbers are different. We've got 8 kilograms on the left-hand side of the first scales, and then the set of scales on the right hand side of the picture, we've got 8 kilograms and 15 kilograms. So you need to work out the value of the yellow square. So remember to start with the red circles and then work out the value of the yellow square. So pause the video, spend however long you need working it out, and then press play, and then I will reveal the answers. Okay, so first of all, I'm going to reveal the answers for the weight of the red circles. The red circles weigh 4 kilograms each, because we've got 8 kilograms and we're splitting that between 2 red circles on the left. So we've got 4 kilograms each, and I've also put that into the red circles on the other set of scales as well. So now we work out the value of the yellow square. So hopefully you've already worked this out. So the answer is 3 kilograms for the yellow square, because the weight that we have on the second set of scales with the 2 black weights, we've got 15 kilograms and 8 kilograms. So together that makes 23 kilograms. We've also got 5 red circles, and they are worth 4 kilograms each. So 5 lots of 4 is 20. And so then we've got 3 kilograms left over, which must be the value of the yellow square. Did you get it right? I hope so. We're going to move on to another problem now and have a look at that one together. Right, so there are 2 more problems we're going to look at. We're going to look at this one together first, and then the next problem afterwards is a bit of a kind of a hot chili challenge extension, which will allow you to actually put some liquid into bottles that you've got at home. So it's a bit of an extra. So that one's not compulsory. You don't have to have a look at that one. That's just a bonus one on the end. But we'll have a look at this one together first. So it says Stanley is making drinks using these jugs. Each drink is 125 millilitres. So Stanley says, if I make 3 more drinks using jug 2, so that's the shorter jug, both jugs will have the same amount of juice in. Is Stanley correct? If not, how much juice will be left in jug 2? So we've got jug 1, which is the taller jug, jug 2, which is the shorter jug, and he's making some drinks by pouring out the juice in the jugs. And each drink that he's going to make is 125 millilitres. And he's going to make 3 more drinks using jug 2. And we need to see whether he's right. He thinks that both jugs will then end up with the same amount in. And if he's not right, we need to work out how much would be left in jug 2. So we need to have a look first of all and see what are the scales actually reading at the moment. How much juice is in those jugs. So I'm going to zoom in so you can see. Okay, so I realise it's not the clearest picture, but hopefully you'll be able to see enough to work out the amount of juice that we've got here. So have a look at jug 1, the taller jug, and see what the measurement is there, and also have a look at jug 2. I want you to have a think about what the measurements are. Pause the video if you need longer, because I'm going to switch in a second to a piece of paper and write down those total amount of juice that we've got there, to make sure you've had a think before that happens. Right, so jug 1 and jug 2. So in jug 1, hopefully you've worked this out, there is 400 millilitres of juice. And in jug 2, it goes all the way up to 1 litre. Now, because the question is talking about millilitres, I think it's sensible if we convert this to millilitres. So how many millilitres are in 1 litre? We discussed this earlier in another question. So what is it? How many litres in a millilitre? How many millilitres in 1 litre? There are 1,000 millilitres. Okay, so that's how much we've got in the jugs. All right, we've got 400 in this one and 1,000 millilitres in this one. Right, let's just have a quick flick back to the problem. So Stanley says if he makes 3 more drinks using jug 2, both jugs will have the same amount of juice in. Okay, so he's going to make 3 more drinks and each drink is 125 millilitres. So let's put that down on paper. 3 lots of 125 he's going to do. Okay, it's 3 lots of 125 millilitres. We're going to do 3 more drinks of 125. And then we're going to take that away from jug 2 and see where we're left. Okay, so to work this one out, remember we can partition this bigger number. So we can do 3 times 100, 3 times 20, and 3 times 5. And then we'll add them up. So what's 3 lots of 100? 300. What's 3 lots of 20? 3 times 20. 20, 20, 20. 60. And 3 times 5. 15. Okay, so we're going to add those ones up. We've got 300, we've got 60, we've got 15. So what's the total? 300 and tens. We've got 6 tens and 1 10. 75 units. So that's how much juice there is in 3 more glasses. Okay, so now we need to take it away from jug 2 because that's where he's getting the juice from. So now we've got 1,000. We're going to take away 375. Now remember I say at school that if you've got a question like this, it's not best to do it in the column method because it's going to be really tricky because you're going to have to do a lot of exchanging back and forth. It's actually easier just to count up. If you're getting to a multiple of 100 or 1,000, just count on. Okay, so to get up to the next 100, how many would that be? Okay, pause if you need more time. So 25 more, and then to get up to 1,000, how many hundreds would we need? Count in hundreds from 400. Pause if you need more time. It's 600 more. So altogether, 625 millilitres are left. Now, let's compare that to jug 1. So is he right? Stanley said that if he made 3 more drinks using jug 2, both jugs would have the same amount left in. So is he right? No, he's not right. And so how much juice will be left in jug 2? 625 millilitres, which is still more than what was in jug 1. So he was wrong, but we were right because we worked it out. Right, let's have a little look at the bonus question, if you'd like to have a look at that. An opportunity for you to get active with some containers in your kitchen too. Okay, bonus problem. Evie says, I know container 1 has more than container 2 in it because the water goes further up the side. So we've got a picture of container 1 and container 2. Is Evie correct? Explain your answer. So let's have a look. She thinks that container 1 has more liquid in than container 2 because the water goes further up the side, which we can see that it does go higher up than in the second container that we've got there. Now have a think. I'm going to zoom in a minute so you can have a look at the scale more easily. But what do you think? Do you think she's correct or do you think she's wrong? Pause the video if you want a bit more time to discuss this with somebody near you or more time to think about it in your head. And now I'll zoom in a little bit
and so you can have a look and read the scales. Right, so again, not a brilliant quality picture, I do apologise, but can you have a look and read those scales now? See if you can work out whether she's right or wrong. Please do pause so you can read them and discuss what you found. So if you're able to see, you can see that container 1 actually has 700 millilitres in. Container 2 actually has 750 millilitres in, so it's not the same. 700 millilitres in container 1, 750 millilitres in container 2. So she is wrong. Now I wonder why she thought that. I wonder why she thought that container 1 had more liquid in than container 2. Because actually when we look at the measurements, it is wrong. Why do you think that she thought that? She was thinking that the water is going further up the side, and it certainly looks like there is more liquid in there. Now, I'm going to explain what your little challenge is now. So this challenge is based on Evie's problem and what she was thinking about how the liquid was coming up higher in the first container, so it must have had more liquid in. Now what you need to do as your extra challenge is to find some different containers in your house or in your kitchen. They could be glasses, they could be cups, they could be old pots, yogurt pots and things, anything at all that your parents will let you use. It does need to be clear, or at least for you to be able to see the liquid through it. Okay, so make sure you can see the liquid through the side of the container. You also need something to measure out some water. Now it doesn't have to be a measuring cup like I've got here. It could just be a spare container, but what you're going to need to do is we're going to be filling up exactly the same amount each time, because then we're going to put that amount of liquid into each of the containers and have a look and see what we find out. Okay, so it doesn't have to be a specific measuring cup, it can just be another container. But think about not having a massive one, so that you, obviously, because it won't fit in all of the little ones, will it, if you've got a massive container full of water for each one. So think about a smaller, medium-sized container or measuring cup. My one is 125 millilitres or half a cup. Okay, that's what I'm going to use. So I'm going to fill this up with water and then just leave it to the side. Right, now I filled up my measuring cup. I didn't do it all the way to the brim, just so that it doesn't splash everywhere and make a mess. But each time I will make sure I fill it up to the same height, so a little bit down from the top, the brim. Now what you need to do first is have a look at your containers. Now for each of the containers that you've got, you are going to pour in this amount of liquid, whichever cup or measuring device you've chosen. And I want you to put your containers in order of how far up the water is going to come in each container. Okay, we're putting the same amount of water in, so none of them are going to have a different amount of water in, but I want you to think about how far up is the water going to come up the side in each container. Okay, and start with a line with the container where it's not going to come up very far, and go along to where you think the container is that's going to be the fullest, or maybe even not fit all the liquid in. So for example, I'm going to put, this is my first one, because I think this container, the water from my measuring cup is not going to come up very far, the least out of all of them. I think that this one, the water may not even fit in, but if it does, it's going to be right near the top. So this one will be at the end of my line. Okay, and then I'm going to organise the rest of them in order of what I think. Okay, now what you would do then is, once you've got your prediction, you've got your line, you're going to go along and you're going to pour the liquid into each container. Now between each go, you obviously need to fill this back up again and then fill up each container in turn. Okay, they will all be in a line depending on how far up you think they're going to go. And then once you've done that, I want you to have a look at the results. Oh, I've got this container here. And you'll have to come down and have a look at the side and see. You'll have to compare how far the liquid has come up between each container. And you can see if you were right. And you can reorder the containers in the correct order if you didn't quite get it right. And then you can think about why. Why was it that actually one container, the water raised further up the side than another container? And you can think about the shape of the container and the space that you have inside. And you can have a talk about that with your families. Okay, so the same amount of liquid in each container. See if your order was correct. Okay, compare them by looking down at the level rather than from above. And then talk about the differences in the containers and why there was a difference, why some containers, even though they might be taller or shorter, like Evie's, actually Evie's container that the water level was higher, actually was less liquid, less amount of water. So you can talk about why that is. So I hope you enjoy that activity. Remember, there's going to be a link in the video, a link under the video for that game that we played at the beginning for reading the scales. But I hope you enjoy this and I hope you have a good week. Bye.